Professor, I believe your microphone is muted.
Well, that sucks. I said a whole bunch of stuff. Let me say it all over again. Okay. Now, some people think they are not sure if they're enrolled in class. Okay. You have to log into your LAVC student portal and see if you're enrolled in the class. If you're not sure, you can email me. So someone emailed me yesterday and said, am I in the class? And the answer was no. So enrolling in the XYZ and the My Haiku have nothing to do with enrolling in the class. Now, if you're not sure how to enroll, so what you're supposed to do is go into your student portal, add to class, and it's supposed to ask you, do you have a permission number? And then you type in the number I gave you. Now, if you can't figure it out, go to the admissions building, first floor, bring all the information about the class ID, and the permission number, and ask them to enroll you, and they'll type it in for you. Okay, so if you're not sure if you're enrolled in it or not, email me, and I will let you know. Okay. Now, the other thing is I have a hard out at 12 o'clock. So after I answer all the questions, I have to run out at 12. I'm going to a doctor's appointment. I'm going to come back. So I probably won't have the what to study set up until sometime tonight. So in the meanwhile, what I would recommend is after class, go through all the homework and then go through the XYZ, make sure you know how to do all the problems and how to input the problems. One of the students yesterday told me she's working on MacBook and she's having a hard time inputting infinity, that when she selects the infinity icon, what happens is it doesn't work. Well, it returns as 0, 0. Now, what you can do is type in 00, lowercase 00, and that should give you infinity. You can try that. I forwarded your email to the IT at XYZ, So hopefully they'll have some kind of recommendation. Now, if you're that person who's having a hard time plugging in infinity on the exam, take a picture of any question where you want to put infinity on. Take a picture of the number, the question, and your answer. And I will double check afterwards to see whether the infinity went through or not. Okay. So just to protect yourself, take a picture, email to me, and then afterwards I'll double check your exam to make sure you got those questions correct until we figure out how to fix this correctly. Okay. Anyone else have questions? Yes, no? Okay. Now, let's finish up section 3.2. So we'll probably do 3.3 and hopefully 3.4. We might get to 3.5, we'll see. Now, yesterday, we sort of finished up with this idea that a way you can tell if two lines are parallel, perpendicular, or neither is by looking at the slope. And if the slopes are the same, they're parallel. And if the slopes are opposite sign and reciprocals, meaning that we flip the numerator and denominator, they're perpendicular. Okay. Now, usually the way they give you this question in XYZ is they give it to you like this. And let me actually even give you the question straight out of XYZ, just so you can sort of see how they do it. Okay, here we go. So let's do this one. Okay, so they'll give you two lines, and what you're supposed to do is convert it into y equal mx plus b. So go ahead and do that. Change this into y is equal to something x plus b plus something, and then change this so this is y is equal to something x plus something. So bring the 6x over, divide everything by 2. Bring the 3x over, divide everything by minus 1.
Professor,
Mm-hmm.
quick question.
Sure.
I think it occurs with the second equation with 6x plus 2y equals 1, but I think you're going to end up getting a fraction for the y-intercept. How would that work on a number line? Because I think I ran into that on the homework where I was given a fraction as the y-intercept, and then the slope was like -2/3. So how would I go about graphing that? Like,
okay. We'll do that in a second.
Okay, yeah.
We'll actually that's the next thing we're going to do. So we'll talk about that. So I'm going to move this over to the other side. And I'm going to divide everything by the same number. Okay. So now do the same thing with this one. Move the x over here and divide everything by 2. So when we compare these two, they're not the same. They're not reciprocals. So then your answer is going to be neither. Okay. Now there are two more kind of questions like this. Let me give everyone a second to copy. And then I had a few students who wanted to add this class, and I sent them permission numbers yesterday. Are there any students where this is your first day, or you haven't been talked to about how the class works? Are you guys here? You can either say yes, or you can just type it in the chat that you're here. First day here? Okay. So hang out after class. So after everyone asks their questions from homework, stay after class and let's see if we can get you comfortable. Okay, Viviani? Okay, now there are two more questions that'll ask the same question, and they deal with horizontal and vertical lines. So one of them will look like this. And then another one will look like this. Now, don't worry about the brackets. That's just decoration. It just means we got two lines, okay? It doesn't really mean anything. It's just pretty. Just like over here, it doesn't really mean anything. It means that these two are different lines. A lot of times when you see things stacked in math, it means this line is the same as this line. This curly brace just sort of means that I've got two things here. This one is not equal to this. They're just two separate things. So sometimes you'll put the curly brace there to just sort of say, I'm not saying that this is equal to this. I'm saying that I've got two objects here.
Professor. Would you call those two numbers, two like equations, a system?
Yes, you would call them a system of equations. Yeah.
All right.
And then that'll be chapter. I think the next chapter will be system of equations. Okay. So now let's play this game. Okay. The easiest way to attack this problem is to just draw them. This right here says go through the x-axis at 2, and this one says go through the x-axis at 3. So we have two lines that are going in exactly the same direction, one at 2 and one at 3. So just by looking at it, you can tell that these lines are parallel. Now, do the same thing here. Graph the x and graph the y, and then figure out whether it's parallel or perpendicular. Okay. So now this one here is we're going through the y-axis at 3. And this one here is we're going through the x-axis at 2. And just by looking at them, you can tell that they're perpendicular. Okay. All right. So let's finish up the last part of this. And I've sort of been slow walking this part because yesterday I taught you how to graph. And then today I'm going to teach you how to graph the same lines. Okay. Now, the reason why we taught you how to graph by plotting points is that you're going to have to plot points once in a while. So in Math 238 and business calculus, you'll do a lot of plotting points. In pre-calculus and trig, you'll do a lot of plotting points. Okay. But when we draw lines, there are sometimes easier ways to draw a line than what we did yesterday. Okay. So in math, sort of the rule of thumb is if there are 2 ways to do things, we always teach you the hard way first. And then we teach you the easy way second. And the reason why we always teach you the easy way second is that if you learn the easy way, you won't learn the hard way. Okay. Now, what I would recommend is be good at graphing one of these techniques. Like 90% of the time, do it the way that you like. Once in a while, using the other technique will be a little bit easier than the other, which is why we show both techniques. But find one that's your favorite, your default go-to, and then if that one is hard to work with, then use the other one. Okay. Now, let's sort of think about slope-intercept. Okay, the formula. So this is still section 3.2. Okay, so if we look at the slope-intercept formula, okay, this is our y-intercept. Think of this as our starting point. This right here is our slope, and think of that as a direction. Now remember, the slope is always up, over, right. Okay. Now, when we sort of theoretically think about slope, about this formula, we always have to start somewhere on the y-axis because the y-intercept. So somewhere on here, that's our starting point. And from there, we move in that direction. So we always start from B on the y-axis, and then the M tells us what direction to go. Okay. So go ahead and copy that, and then we'll try something basic. Basic, not meaning that it's easy, basic meaning that it's the first step. We'll make it progressively harder. All right, now, on your exam, all I care about is whether the line is correct or not. So you use whichever technique you like, okay? So let's say I ask you to graph this. So let me make a little graph. Now, if you're graphing using X and Y points, you would say, well, I see a fraction, so I would plug in 0, 3, 6. And if you did that, you would get the exact same line as if you use this slope-intercept technique. Okay? Now, what we want to do is we want to start from here. So put a point at -4 on the graph. Okay, -4 on the y-axis. Put a dot there. So that'll be here. Okay, now, what we want to do next is then use the 2/3 to give us a direction. So the 2/3 tells us to go up 2 and go 3 to the right. So what you're doing is you're counting 2 boxes, 1, 2, and then you're going 3 to the right. 1, 2, 3. So what you're doing is you're drawing a little triangle, right? 2 up, 3 to the right, and then you draw your line. All right. So let's try doing that again. And just know that if we had used 0, 3, 6, we would have gotten this point, and then one more point over here. So let's try this again. Graph y is equal to -3 x plus 2. So when you have the -3, put the negative on top. So this will say that you are going down 3, right 1. So you're always going to the right. Whether you go up or down is completely dependent on the sign. So if you're negative, you're going down. If you're positive, you're going up. Okay. So try graphing that. Start from this point and then tick these off. So we're going to start from 2. We're going to go down 3. And then we're going to go over 1. So we have this triangle here. And then we're done. Okay, let's try another one. Try that one. Okay. So we're going to start at -1. Okay. And then when I look at 3, it means go up 1, right 3. That's right. Yeah, go up 3, right 1. So it doesn't matter whether I go up from here. Now remember, all you want to do is count boxes. 1 box, 2 box, 3 box. Okay. So I'm going to go up to here, 1 to the right, and there you go. Okay. Let's do one more. I'm sorry. Now, most of my students in the beginning don't like doing this because you just learned a new way yesterday and I'm barely getting comfortable with it. Now you're telling me to do something new. What I recommend is for the first section yesterday, 3.1, do it the way I taught you. And then in this section, do it this way. What you'll probably find is you probably like this technique a little bit better. Now, I know how to do the other way in a pinch, but I would get really good at this way because this is generally how people tend to remember how to do the section. Okay. Now, we have a bunch of straightforward questions here. Now, show you how to get out of the weeds in case you get something that's a little nasty. Okay. All right. Now, over here, we're going to start from 3. Okay. And then when I have -1/4, put the negative on top. So you're going down here and right that way. So we're going down 1, and then we're going to count 4 boxes. 1, 2, 3, 4 boxes. And we're going down. Okay, now, it's not in this section, but in the next section, they're going to tell you that f of x and y are the same thing. So let me sort of mention that. Okay. F of x is equal to y. So f of x is another way of writing y. Okay, you don't have to know what f of x is yet, but just know that this function symbol, f of x and y, can be used interchangeably. You don't have to be given permission. We assume that f of x and y mean the same thing. Now, I'll go into detail probably in the last hour on what f of x is. But for right now, just know that f of x and y can be used interchangeably. So you may get a problem that says something like this. Just know that this can be changed to this. They're the same thing. So when they ask you to graph f of x, just graph it as if it was a y. You could usually using slope-intercept is the easiest way to graph an f of x. Okay, so this can be changed to this, and then go ahead and graph it using slope-intercept. That's my starting point. 1. Okay, so do the 1/3. So we go over 3, up 1. We're done. Okay, so just know that if you see this, it's the same problem that we've been doing up till now. Okay. Now, let's play in some other directions with this. So the first sort of manipulation is this, is that sometimes we'll call the y f of x. Okay. Now let's look at some of the problems that we solved yesterday, and let's solve them using slope-intercept. So for example, let's look at the technique where we something like this. Now, this one you may want to solve using the x and y intercepts. You can just do 0, 0, and that one works, not too hard, and it's doable. But let's just say you're one of those people where you're like, I really hate your rules. I really don't like to memorize them. I'd rather just always isolate the y and not care. And that's fine. A lot of people are like that. In fact, most people are like that. So go ahead and convert this to y equal to mx plus b. Okay, so move the 2x over, divide everything by 3. Okay. So you have 2x plus 3y is equal to 6. And then we'll subtract 2x from both sides. And then we'll divide everything by 3. That. Now go ahead and graph that. Okay, go down here, down to over 3, and you're done. So you have a choice. This is an or. You can either plug in 0, 0, or you can do this. It's really up to you. Use the technique that you think is easier. What we're doing is we're trying to give you options. Right? So let's give you another problem. So let's give you something like graph. 2y plus x is equal to let's make it 5. And then someone had to ask the question of, what do I do? How do I deal with fractions? This is the one where we're going to deal with it. Now, if you were going to plot points, usually this is easier for plotting points. You have you have x all by itself, so then you put in 0, 1, 2, and it's easy to plug in 0, 1, 2. But let's just say you're one of those people where you're like, forget it. I hate those rules. What I want to do is just have one rule, and I'll just always use that rule. That's fine. Go ahead, convert this to y equal mx plus b. Both techniques work. Excuse me. So you get 2y plus x is equal to 5. And then you're going to subtract x from both sides. You get 2y is equal to negative x plus 5. And then you'll divide everything by 2. So then this turns into y is equal to negative 1/2 x plus. Now the best thing to do whenever you have a fraction for the y-intercept is to convert it into a mixed number. So where you're going to start from is 2.5. 2.5 is in between 3 and 2. Okay, so if you're to graph this, this is 1, 2, 3. 2.5 will be right there, right in between 2 and 3. Okay. Now from here, you're going to go down 1, which is halfway, and then over 2. Okay, so when you go down 1, remember that you're going to be at a half. So go ahead and try that.
Professor, I have a question.
Sure.
When it doesn't give you the 0.5s on the graph on XYZ, and you still get your slope as like 1/2, does it mean you're doing something wrong?
Your slope is the issue is when your y-intercept is 1/2.
Oh, okay.
Right. This being a fraction is okay.
Yeah.
Because you're gonna break it up into how many up and how many to the right. The issue is when you get this as a y-intercept.
Okay.
Okay, that's where it's bad. That's a fraction.
All right.
Okay. All right. Now, what I'm going to do is I'm going to go down, and then I'm going to go over 2. So here's 1, then went over 2. Okay. Now I'm going to try to give you problems. Actually, I can't promise anything. I'm going to give you whatever XYZ gives you. It's not my intent for you to get a fraction here, but since the numbers are random, but they're random with a purpose. The ones I look at, I will try to pick the ones that don't give you a fraction, but I can't guarantee it. Now, if you're willing to have a fraction in your y-intercept, then this graphing with y equal mx plus b will always work. The only time it's a little bit easier is when you get something like this, when you go like, I don't like fractions. Maybe I'll plug in numbers into y and see if that's a little bit easier. So this is the only this is when it gets a little nasty with slope intercept. But if you're okay with like, that's a fraction, I'm good with that. Somewhere between 2 and 3, I'll live with that. Then you should be okay with this technique.
Professor?
Yes?
What if we need a problem like x equals 3y?
Okay, x equals 3y?
Yes.
Okay, let's try doing that one. Let me make sure I take a picture of this, and then let's do that one. That's a good one. Okay, so you're asking a really smart question. That's the right question to ask at this moment. Okay, so let's say we have x is equal to 3y. Now, one way to attack this problem is you go, I've got y all by x all by itself, so I'm going to put 0, 1, 2 into y. Now, let's just say I'm not that person. I don't like that. I like that other way. That's okay. We can convert to y equal to mx plus b. Okay. So I'm going to write the 3y on this side and the x on that side. Okay. I'll just move this to this side, this to that side. Now I need to isolate the y. So I'm going to divide everything by 3.
Professor?
Go ahead.
So when you convert the 3y to the next side, don't you change the sign?
Think of it this way. If you have something like this, if I swap sides, the equality still holds.
Oh, okay.
Okay. Now, what you could do if you wanted to, what you're talking about is I have x is equal to 3y, and then I want to switch sides, so I subtract x, subtract 3y, subtract 3y, and then I get minus 3y is equal to minus x, and then I divide both by -1, and then I get 3y is equal to x. So we end up in the same place, but with just a lot less pain.
Okay.
Okay? All right. Okay. Now, this is such a good question you asked. You're asking a really good one. This was going to be my next example. Okay, so now we're going to divide both by 3, and now we have y is equal to 1/3 x. Okay? What's my y-intercept? Even though it's not there, it's there. Okay? So 0 will be my y-intercept. So what you're going to do when you graph it, you're going to just start from here. Okay. All right. So go ahead and let everyone else copy and go ahead and finish that. From there, go up 1, 3 right.
Thank you.
You're welcome. 1/3, up 1, 3 right, up 1, 3 right. Then let's go down like that. Okay, and this is just going to be a core ability. Okay. Now we did pretty good. We banged that out pretty fast. Let's do this. Let's take a little bit of an early break because we got a long slog on the next one. Is another pretty heavy one. Let's take a break to 9:05 and then we'll get going again. Okay, so let's take a 13-minute break. And then I'll leave this up for everyone to copy. Okay, let's get going. We're going to go to section 3.3. But before we go to section 3.3, I just sort of want to explain why we're teaching you these shapes. Okay. Now, if you actually look at the coronavirus, so this right here is the coronavirus of how many people in China have been affected. Okay, and this is way back in March. Now, when you look at the coronavirus in China, you see all these different shapes. Over here, you see a line. So we could talk about the coronavirus here using y equal mx plus b. Mx plus b would be our starting point, and the m would tell us how many people are getting infected per day. Now, later, we're going to learn about logs. And you can see that this is a log, meaning that every day there is a smaller fraction of people who are getting the disease. So before, maybe 1,000 people were getting it a day. Then you multiply it by 75%, and then the next week you multiply it by 75%, and you start to get this flattening kind of thing. It's not quite flat, but it's flattening, and that's a log. Over here, you're seeing this shape over here. This is a square root. This over here, for the rest of the world, is exponential, meaning that you have some x to the n. Now, what we do in real life is that we graph how many people have the infection, and by its shape, we can tell you how people are, what things people are doing, and whether they're working or not. So what normally happens is you start with a shape, and then I want an equation that comes off of that shape. And that's what we're going to do in this section. We're going to start with a line, and we're going to say, well, now for me to talk about this line, how do I turn that line into a line equation, into something mathematical? Now, let me show you a different example. So if I were to go to, let's see, stop sharing. Let me bring up another one. Give me 1 second. Let me share a screen with you. So I usually show this in all my classes. Okay, so if we look at this, oops. Where are we? There we go. And then let's make this bigger. Okay, again, what this line over here shows is how much money you make. Okay, I'm sorry. This right here shows you how much productivity you are. How much work are you doing? Okay, over here, this is a line, and it shows you how much money you're making. Okay. Now, what you're seeing globally, why are you seeing these global demonstrations for George Floyd? And a lot of it has to do with, this is the graph for the United States, but if you look at every other country, including China, you would see the same graph. Something happened in 1973. Prior to 1973, you could see that this line and that line were exactly the same. So if I worked twice as much, I got twice as much money. So if I work twice as many hours, or I was just twice as productive, I'm just faster than other people, well, I made more money. Now, what happened in 1973 is that relationship got broken. What happened in 1973 is the amount of money we received was flat, but from 1973 to 2013, you have to do 2.5 times more to get the same compensation. So why are people so upset? It's because for the last 50 years, we've been on this trend where you have to do more work for the same salary. Now, for some people, that's not too hard. So, for example, I'm a computer programmer. The computer gets faster every 3-4 years, it doubles in speed. So I can program just as fast as I did before, but since the tool that I'm using is faster, guess what? I don't have to work harder. My salary goes up because I am more and more productive because the tool I'm using is more productive. But if you look at other people who make hamburgers or who are driving a forklift or driving a truck, you can't drive faster. At a certain point, there's only so many hours in the day. And what happened was we went, okay, then maybe what we should do is have our wife work. And you could earn the same amount of money by having your wife work. In fact, in the beginning, you were doing a little bit better because now you had 2 salaries. Now, as more women worked, we had this issue that women got paid 70 cents on the hour that men got. So then you see this push that why aren't we paying women more? And the husbands are going, yeah, why aren't we paying women more? Why? It's because the productivity keeps going up, but their hourly compensation becomes flat. Now, what you saw in the during the Bush era is that we had that crash where people took on too much debt. Why did they take on too much debt? Because to live the same way, you now, if your wife was working and you were working, that's at 200%. You had to either live poorer or you had to borrow money. And what a lot of people did was borrow money they couldn't pay back. So when we talk about any kind of grown-up issue, what we're going to do is we're going to get data, and somehow I need to talk about the data in a smart way. This is flat. My slope is 0. This over here, let's see, from 1973. So if we, oops, sorry. Let me annotate it. So if we look at this slope, let's go to 2003. This is 10 years. And then when you look at this height, that is 100% to 200%. So your slope is 100%. Oops, sorry. Let me type it, come faster typing. Your slope is 100% divided by 10 years, which means that 10% per year. In order for you to live exactly how you were living before, you had to make an extra 10% every year. You either had to make that 10% from investments, or you had to work a little bit longer, or you had to find someone else, maybe your kid, maybe your wife, you had to get her to work. But every year, you had to be 10% more productive in order to have the same lifestyle. So the reason why we're teaching you slope, the reason why we're teaching graphing, and the reason why we're going to teach you to say, here's a graph, now convert it into a line equation so we can manipulate it and talk more detail about it, is because anytime you have any kind of grown-up conversation of why is the COVID growing like it is in the United States and why is it different in other countries? Why are people so upset and in the streets now in the way that they've never been? Why do we see white people protesting with black people where we didn't before? Why won't people go home? Is because any of those kind of analysis is going to require you to take a graph and to change it into something algebraic. Okay, so let's get going. But just so you know, if you ask what happened in 1973, computers. In 1973, the first laptops and computers came out. I mean, computers had been around since the 1940s during World War II, but in terms of computers just being everywhere, 1973. And once 1973 happened and computers started coming out, you no longer needed secretaries. You didn't mail as much, so you don't need a postal worker. The postal worker, if there's a lot of postal workers, they have lots of cars, so then you're selling a lot of cars. Their cars break, so you don't need fewer repairmen. If those people aren't working, they don't go to restaurants, so you need fewer restaurants. So you have this trickle down that as we just sort of remove people from the economy, the people who support them, who feed them, they leave out of the economy also. Now, the reason why you never ever hear that it's computers in politics is because it's hard to get elected on the idea that this computer, if you got rid of your iPhone, more people would have a job. More people would have a job. You can't get elected that way. It's easier to get elected to say, well, the reason why this is happening is refugees, is undocumented people. So all these people, right, all these authoritarian leaders are getting elected because people are feeling this unrest. Now, they feel that 85% of this is from technology, and 15% of it is from globalization, meaning that I can bring my manufacturing to China, but it's hard to demonize your laptop, which is why whenever you listen to politics, they talk about the 15%, not the 85%, right? The people getting blamed are undocumented workers, refugees, manufacturing in China, when really that's a small percentage of why this is happening. In France, they are blaming the Muslim refugees. In Germany, they're doing the same thing. In England, they're doing Brexit because they're blaming the rest of Europe. Every authoritarian leader has someone that they're blaming, when really it's just our technology is faster. We need fewer people to make this economy run. Okay. So let me get off the soapbox. But I just wanted to explain that the stuff we're doing, like if you're going to be asked to solve a hard problem at work or analyze a hard problem at work, the stuff we're doing with the graphing is actually relevant. Okay. Now, let's look at line equations. So what we've been doing so far is that we've taken a graph, we've taken a line equation, and then we drew a line. So this is a line equation. This is a graph. And this is what section 3.1 and section 3.2 were about. Now, what we're going to do is we're going to go the opposite direction. I went and collected data. I put the data on a graph, and man, it looks like a line. How do I convert it into a line equation so now I can get the slope? Now I can get the y-axis. Now I can tell whether it's perpendicular to things. Now I can tell if it's parallel to something. Okay, so this is going to be section 3.3. I start with a graph and I want to get a line equation. Okay, now we have three types of line equations. We have the standard form. And we really don't use that in this class. We kind of tell you because it's important. Not now. Maybe, which class is that? Multivariable calculus. So if you take trig, pre-calc, calc 1, calc 2, calc 3, then yeah, it starts to be important. About 5 classes from now. Okay, So this is the first one, but we're not going to use it too much. Now, the next one was slope-intercept. And we like slope-intercept. The reason why we like slope-intercept is nice. You know, I got a slope here. I have an intercept. And it's nice because it gives me information. If I isolate the y, I know a little bit about this graph. Now, when we play this game, there are limitations. See, the problem here is that my starting point is on the y-axis. Okay. And then from that starting point, I'll go in some direction. Okay. So let me let people copy. Now, this is limited because I don't want to always start my line from the y-axis. What I'd really like is to have a formula where I can start from anywhere, like here, and go in that direction. I really want a formula that's a little more general, so my starting point can be anywhere. In this case, we're going to call my starting point x1, y1, right? It's just a point. And we have a formula for that, and we call it point slope. And this looks like y minus y1 equals mx minus x1. So this is my slope, and this is my starting point. Okay, now, well, let me give people a chance to copy. Okay. Now, I sort of told you that exists, and in order to keep my job, I have to tell you that this is a thing, but we're really not going to use it. We're really going to use this one and this one. So the question always is in this section is, which one, when do I use this and when do I use this? Okay. This one here, use when you have a Y-intercept. If a problem doesn't say Y-intercept, doesn't show you a Y-intercept, you're going to use this one. If it says Y-intercept, this is the easier one to use. Okay. Now, let me give everyone a chance to sort of breathe and copy.
Professor,
Go ahead.
but you can still use slope intercept if a y-intercept isn't provided with a point, right?
No, you can, if they give you a point, then you have to use this one.
But if you have the slope and a point, can't you still use slope intercept form if you plug in the point?
No, because okay, so I'm gonna contrast two questions, exactly like you're saying, and you'll see it. Okay, so let me contrast the two questions. Okay, so let's contrast the difference between this and this. Okay. Find the line equation of the line with slope equal to 2 and y-intercept equal to, let's say, -5. Okay, I'm going to contrast that with find the line equation of the line with slope equal to 3 going through 2, -4.
Professor, I have a question.
Sure, go ahead.
Instead of using point slope form, can't we just put the information on a graph and then start from that point and go on with the slope?
You could. The only problem with that is that in real life, you have fractions.
Oh, all right.
Right. So in terms of what we're doing in this class, like we're doing a lot of toys, fractions suck, decimals suck. Let's just use whole numbers and integers. And in terms of that, yeah, you can. But in terms of like if you're going to use this for work, you're going to have to deal with fractions and decimals, most likely decimals. You really don't use fractions much at work in a real job, but you'll use, the data will have decimals. Okay, so go ahead, copy those two. And I want you to see the only difference between these two is basically this and that. Okay. Now, this one says y-intercept. So whenever they say y-intercept, we're just going to use this formula because it just makes our life easier. Y is equal to something x plus something. And you just fill in the boxes. This is 2. This is -5. And then we're done. Okay, now, the reason why we can't use the slope intercept for this one is I need to know where this point is. 0, comma, blank. That's what the y-intercept is. I know where a point over here is, 2, -4, but that doesn't help me. In order to do use this formula, this tells me that, oh, over here, that's where I'm starting from. I have to start from a point that's on the y-axis. That's why when you're trying to go from graph to line, this is limited because it's only limited if you know where the line goes through the y-axis. Over here, I don't know where this goes to the line axis. I only know that I start here and then I go up. So I have to use this formula. So I have y minus blank is equal to blank, x minus blank. And now you just fill in the boxes.
Professor.
Go ahead.
What I was trying to say that for the problem on the right where you're not provided the y-intercept, if you set up the equation y equals 3x plus b and you plug in 2, -4 into the y and x, you'll get the slope-intercept equation.
Okay, so what you're saying is this, right? You're saying y is equal to mx plus b, right? And then you're saying you're going to put -4 here, right? And then you'll get, then you put 3 here, and then you'll put 2 there. And what'll happen is that'll actually give you b.
Yeah.
Yeah. So in terms of that, yeah, you can do it.
Okay, because that's what I was doing on the homework. I wanted to make sure it's because I got it right on the homework.
Yeah, that'll work. And now you have the slope intercept, and absolutely that works. Okay. Okay. Now, what you can do over here is you can put in the slope 3. This is the y value. And then this is 2. So this is y plus 4 is equal to 3x minus 2. Now, normally, if I was giving you a written exam, I'd go like, that's good. I'm good there. But XYZ wants you to convert this into slope intercept. So what you'll have to do is you'll have to go further. You'll have to go y plus 4 is equal to 3x minus 6. And then you'll subtract 4 from both sides. And you'll get y is equal to 3x minus 10. Okay. Now, that's nice. Seems pretty straightforward. Since this is an open book, open note test, that's awesome. You know, I'll have the formulas all set up and then I'll knock that out. But the problem is, I'm not giving you that problem. That problem is too easy. We've got to go one more level. Okay. Now, listen to how I'm telling you. This is how I will give it to you on the test. Okay, not if, not maybe. This is how I'm going to give it to you on the test. Right? So let's put a little star next to this one, because I always put this one on the test. Of the line through. Okay. Now the only reason why I'm giving you this line is that if you can do this problem, you can do the other two problems. So that's why I always give you this harder version. Okay. Now, remember what I said. Did I really call this a slope? Okay. Remember what I said. You only use this one if it says Y-intercept. Okay, that's the only time you use this formula. Now, when I read this, it doesn't mention Y-intercept at all. Well, then I guess I have to use this. So I need a point on the line, and I got a point on the line. In fact, I got two of them. It's an embarrassment of riches, but I don't have a slope. But we can find the slope by using this formula here, the YQ minus Y1 formula. Okay, so first let's find the slope. So let's do that first. So go ahead and find the slope. Okay, so then we're going to get m is equal to minus 2 minus 7, right? Subtract the y's, then 1 minus 3. So I get minus 9 over minus 2. Okay. Now, I wanted to give you the worst version of this problem just so you have an example of it. That now you have a fraction, now you're going to have to deal with a fraction. Okay. So I wanted to walk you through it. Okay. So now we have y minus y1 equals mx minus x1. Now, you have the option to either plug in this one or this one. You're going to have to ignore one of the points. So pick in the one that has numbers that you think are the easiest to deal with. So it doesn't matter which one you pick, because once you simplify it into y equal mx plus b, you'll get exactly the same equation. So for me, in terms of this one, I recommend let's use this one. Okay. So put this in for m and put this number into here. And then at the end, we've got to convert this to y equal mx plus b for you to get full points. So you should have y minus minus 2 is equal to 9 over 2 x minus 1. So go ahead and distribute that. So now you have y plus 2 is equal to 9 over 2x minus 9 over 2. So now I want to subtract this, and I get y is equal to 9 over 2x minus 9 over 2 minus 2 over 1, and my lowest common denominator is 2. So I'm getting y is equal to 9 over 2x minus 9 over 2 minus 4 over 2. Now, once you get a common denominator, what you want to do is put all the signs on top like that. And that's the easiest way to add positive and negative fractions, is get a common denominator and then push the negatives up on top. And then y is equal to 9 over 2x minus 13 over 2. Now, sometimes you get lucky and your slope is an integer and you don't have to deal with all this fraction nonsense. But I want to make sure that you have an example of the hardest way to do this problem. Okay, so go ahead and copy that. We'll do one more. We'll do one more. All right. So if you're unhappy, you're a normal human being. Okay, now The way the test is built. Okay, let me show you real quick. The way the test is built, you will be able to see all the problems all at once. So you'll be able to scroll up and down. So right now, when you do your homework, it's one at a time, and you have to click on it to see it. The way I set up your quiz, all of your problems will be visible. So since it's a time test and every question is worth the same amount, the way you attack the test is do the problems you can do fast first. Don't go 1, 2, 3. Okay. Start with the ones that you know that you're comfortable with, that you can do fast. All the ones you're not sure of, just mark down with a question mark. 2 is a question mark, 3 is a question mark. So once you do the questions that you can do fast, then what you do is you do the questions that I know I can do, but it's going to take a little bit of time. You always do the questions that you're not sure about last, because you're probably going to get it wrong anyways. Why spend a lot of time? You should spend the most time on the questions that you're sure you can get if you weren't rushing. And then the ones that you're sure you can get, but they'll take a little bit of time, so I want to do those next. And then the ones you're not sure of, you do them last. Okay? Most people go the other direction where they get stuck and they'll just sit staring at it. Drop it and move forward. Okay.
I have a question about the test.
Sure.
So it'll become accessible today?
No, Sunday at 5 o'clock.
Sunday at 5?
Yeah, Sunday at 5. The reason why is, say that again?
Until when?
Until Tuesday, 8 a.m., right before class starts.
Thank you.
Okay. Now, the reason why it's going to be accessible Sunday is you're supposed to be studying. And the whole reason why I'm going to make a practice test available for you, probably late tonight or Saturday morning, is because what you think you know, I want to show you that, oh my God, I got to study more. Okay? So if you've never conquered this is like a 40, 50 hour a week class in terms of class and sitting home miserable. So it should suck. Now, if you took my class over the fall, it would still suck, but it would suck over 4 months, not over 1 month. Okay. I always have teachers go, why do you tell them it sucks? Like, didn't it suck for you? It sucked for me. They're like, yeah, it sucked for me. Then why lie? I hated teachers who are like, oh, this math is so beautiful. I love doing this. Like, I'll tell you, I've never met a teacher that works here that does math on the side as a hobby. Okay, now find the line equation of the line going through. Actually, I take that back. There's 3 professors who will do it as a hobby. 4. There's 4 that do. Yeah, that looks miserable enough. Let's do that one. There's one teacher we have where she goes on a cruise ship with her family and she likes to write math worksheets. That's her happiness. So on the cruise ship, her kids go swimming, her husband goes and plays bridge, and then she sits with a cocktail and she makes math worksheets. And that's her happy place. And then if you're doing this right, by about next week, you should be dreaming about math. There will be some of you that are already dreaming about math, but by about next week, if you're going to pass, there'll be a bunch of you who are just obsessively, when you've fallen asleep, doing math. Okay, so first find the slope. Okay. So once you get the slope, pop it into here. Now, just to make our life easier, let's all use this one. That way I don't have to do this problem twice with that point. Let's just use that one. I think that one's easier. Okay. So you should get y minus blank. All you're doing is filling in the boxes. So this is y, this is slope, and then this is x. So go ahead and distribute this, and then you're going to add this to that. Now let's bring the 3 to the other side. Oh, I forgot my X. All right, so go get the common denominator and see if you can do that last little bit. That's the part that scares everyone. Let's get a common denominator. So now we have y is equal to 5 over 3x. Okay. Y is equal 5 over 3x minus 10 minus 9 over 3. Y is equal to 5 over 3x. Okay, so that's the hardest version of this problem. Okay. You may get a fraction, you may not get it, since x, y, z uses random numbers. You could get it, you could not get it. It's random. Okay, so let's finish copying that, and then we're going to.
Professor,
Go ahead.
from where did you get the 3 over 3?
The 3 over 3 over here?
Yes.
Okay. So what's happening is I'm right here. So let's put a microscope on it. Let me put it over here. Okay. What I'm trying to solve in that little spot is, and then this is going to be the part that's hard. So the minus 3 comes from bringing this over here. Now, the first thing I want to do is I want to turn this into a fraction. So I'll put a 1 underneath it. Now, I need to change this into, change the denominator into 3 because I need a common denominator. So since my denominator is 3 here, in order to change this into a number that is equal to -3, but has the denominator 3, you multiply it by the same number over the same number. Okay. So if I just look at this, 9 divided by 3, that's going to be -3. So this number has the same amount as this, but it has the same denominator.
Oh, okay.
Okay, is that better? Okay. And then what will happen is like that. Okay. Now, that question is definitely going to be there. Whether this is a fraction or not, I'm not sure, but that question will be there. And if you were to ask me, am I really into fractions? Do I think that's really important? And the answer is no. If we weren't using XYZ, and I just tell you, use a calculator and give me a decimal. But because we're using XYZ, we just don't have that option. So you're going to have to learn that last little move. Now, the other question that's definitely going to be on the test, so put a star next to it. And then let me pop it up here. So this is section 3.3. Okay. There'll be question 2 from XYZ. So let me share screen with you. Okay. So I want you to be able to go from looking at a line and then write a line equation. Okay. So the key thing here is I've got 2 options. I've got let's annotate. I've got 2 options. I got y is equal to mx plus b, and I have y minus y1 is equal to x minus x1. So for this one, the question is there a y-intercept? And the answer is, yeah, there's a y-intercept. There's a y-intercept right here. Let me. Oops, sorry. Okay, there we go. All right. So in this case, my b is equal to 2. Okay. Now, go ahead and see if you can figure out what the slope is, right? The slope is from this point, one corner, to another, someplace else that has a corner. So it goes through here. Oops, again, sorry. Okay, so when I'm figuring out my slope, just like we did before, this is 2, this is 3, oh, sorry, this is -2. Yikes, let me erase that. This right here is -2. This over here is 3. So then my slope is -2/3. So go ahead and put your b and m in there, and that gives you your line equation. Then we're done. So this question will definitely be on there. And the key thing here is, can you look at a line, find its y-intercept, find its slope, and then can you write it out? Okay. Let me try giving you another one just like this. So this one is question 2 on your homework. So let me pop up something like that on your homework. Oops. Mouse, there we go. Let's go to this class. 3.2, 3.3. Questions. Oops, I didn't mean to do that. Sorry about that. Question 2. Okay, so go ahead and try doing this one.
Professor,
Go ahead.
you're showing us the same graph.
Oh, I'm sorry, you're a little bit far away from your microphone. I couldn't hear you. What did you say?
I'm saying you're showing us the same graph.
This is the same graph?
Yes.
I think it's different from what we did. We could try a different one. Let's see. No, this is different from the last one we did.
I think the screen share is frozen.
Oh, is it? Oh, okay. Let me try a new screen share. Thank you for letting me know. Okay. Is that better?
Yeah, there's a different one.
Okay, great. Okay, we're all on this. Thank you for letting me know. Okay, so let's see. So the first thing I see is I can see that my y-intercept is equal to -4. Okay, so go ahead and find the slope. Okay, so look where that line goes through corner to corner. Let's see if this works. Here to, oh, here, here to, here. Now, if you didn't want to do that, you could also do something smaller. Oops, let me pick a different color. You could have also picked something that looks like this corner to this corner, and this corner to that corner. That works also. I'm just going to do the big one just so I can show you that you would have to simplify that. So when we're going left to right, this is going down 4. And then when we're going, I'm sorry, and then when we're going left to right, this is going across 6. Okay, so figure out what that slope is. Okay, so my slope is minus negative 4 over 6, which is equal to negative 2 over 3. Okay, so go ahead and plug it into the y equals mx plus b. So fill out the m and fill out the b. And then you're done. Okay, so just remind yourself, section 3.3, number 2, definitely on the test. Okay. So let's do this. Let's take a break, a 10-minute break, come back at 10:25, and then we're almost done with this section. We'll finish this section and we'll start the next one. I'm not sure if 3.4 is on the quiz or not. It may be, it may not be. We'll see how far we go and then we'll talk about it. Okay? All right. So everyone hang in there. Okay, so let's finish up this section. Let's do the last little bit of it. Okay. So there's a little cleanup to do. Now, these questions can be asked one of a number of different ways. So I'm going to show you the different ways they're being asked. A second. Okay. Okay. Find the equation of the horizontal line. Now they could say it like that, or they can say of the line with slope equal to 0. Sometimes they'll use this line, sometimes they'll use this line. The way you answer the question is exactly the same. Going through okay. Horizontal lines have slope equal to 0. Okay. Now, let's think about a horizontal line. Or horizontal line goes through the y-axis. So the line equation, right, because it's horizontal, is going to be y is equal to. And the question is, what's y equal to in this case? 7. And then that's your line equation. Okay. So what you're looking for is what axis does this line go through? And then what is that coordinate? Okay. What axis does a horizontal line go through? Okay. It goes through y, and then you just say, well, what's my y value? 7. So what's happening here is that I have this point 2, 7. This is 7. We're going through the y-axis at 7. Okay, now let's look at its vertical counterpoint. Okay. Find the equation of the vertical line Try doing the same thing for this one. So now this one will look like, then we're going to go through the vertical line. So the vertical line goes through the x-axis. So you're going to have x is equal to, in this case, 2. Okay. Now, there's also a pair of questions. Okay. Find the equation going through that is, okay, now I'm going to, so this is, I'm going to give 2 questions that have the same setup. Parallel to x plus 4 is equal to 0. Parallel to y is equal to 2. Oh, sorry, y is equal to, let's make it 5, something different. Okay. And just know that this is the same thing as x is equal to -4. Okay, now let's think about this. X equal to -4 looks like this. I'm going through the x-axis at -4. Okay, so a line that's parallel to it is also going through the x-axis. So it should have the same form. X is equal to, and then whatever x is 2, right? That's my x. Right, so if this is vertical, then this will be vertical. These line equations should have the same form. And the same thing will happen over here. This is, oops, I'm sorry, y is equal to 5. Then a line that's parallel to it will also go through the same axis. So you should have y is equal to 7. Right there is y. Now, we're going to have the same setup. Okay, so this setup is the same for all four of these questions. Okay. Perpendicular to, I'll get out of your way in a second.
Professor?
Go ahead.
So, when it says parallel to y equals 5, right? So the
Yep.
graph you graphed the 5 on the top. And then
Oh, yeah, we can put that up here, sure.
Mhm.
That's okay, so go ahead and do those other two. So when it's perpendicular, if you're saying perpendicular is something going this direction, then it'll be that direction, right? Perpendicular is something in this direction will be in this direction. So in this case, we have x equal to 3. So we're going through x at 3. So something perpendicular will look like this. So we're going through the y at 7. So then over here, we'll get something that looks like y equal 4. And then perpendicular will look like this.
Professor, it should be a -4, right?
-4, okay. I'll just cheat. Sure. I won't cheat. So let me go like this. Thank you. Okay. Take a picture of this. And then we have 2 more problems to do, and then we're done with this. Oh my God, this took forever section. Okay, so go and copy that. So we're going to have the same setup, except this time we're not going to have horizontal or perpendicular line. We're not going to have vertical or horizontal lines. All right, so find the equation going through here that's parallel to this. And then we'll do the same setup over here. So this setup, this question, this question. Okay, so let's go through these problems. Now, these problems are a little bit harder because we don't have the luxury of saying horizontal lines are parallel to horizontal lines and they're perpendicular to vertical lines. Okay. Now, remember what I told you, that we have two formulas. We have y is equal to mx plus b, and then we have y minus y1 equals mx minus x1. Okay. Now, the question you have to ask yourself if you're going to use this one is there a y-intercept? So let me see. It doesn't say y-intercept there. It doesn't say y-intercept here. So it doesn't say y-intercept anywhere, which means that we have to use this problem, this equation. But we're in luck. We have 2 points. But we have to find the slope. Okay. Now, the good thing is that we have some slope information. We know that parallel lines have the same slope. So if I can find the slope here, I can just plug it in there. Okay. So what I want to do is find the slope from here. And then just to make our life easier, I'm just going to make this a 6. That way we won't have fractions. So let's just make our life easier in this problem. Let's just make that a 6, and let's move on with our lives. Because I want to get to the next section. Okay, so go ahead and work on that. And then I'm going to cap the exam at this section. We'll start the next section, but I don't want people to be stressed or rushed. So our quiz will go up to this section. Okay? And then whatever we do after this section is just set up for what we do on Monday.
So 3.4 won't be included in the quiz.
Yeah, we'll just go up to 3.3.
Okay.
And then we're in good shape. Last winter, I think we got up to exactly this point also. So we're in good shape. We don't have to rush.
Will the quiz be on XYZ?
It'll be on XYZ.
Like, what time is it available?
5 o'clock on Sunday.
5 o'clock. Oh, okay. Oh, okay. So like
Okay.
the test.
And then you
Thank
have
you.
from 5 o'clock on Sunday to Tuesday at 8 a.m. Okay. So those of you who have jobs, you just wake up an hour early. Those of you who have kids, take a nap on Sunday and wait for your kids to fall asleep, and then you do it. I mean, I'm trying to give you guys as many options as possible. Okay. So let's do this. We're gonna subtract 6x from both sides. And then divide everything by 3. Minus 2x plus 2. Okay, so here's my slope. This line is supposed to be parallel to this line, which is why, so take this, which is why this will now have the same slope. -2. Okay, and then we'll convert it into slope-intercept. And then that'll be your answer. Okay, so let's do the same thing here. Now, I already found the slope for you, and we know that the slope of perpendicular lines are the negative reciprocal. So this is going to be the same. The only difference is the slope is going to be the negative reciprocal. So go ahead and see if you can do that. Okay, see if you can fill that out. Oh, and then, I'm sorry, we'll make this exactly the same, okay? So you don't have to redo this. This right here is the same slope as there. So let's just do the same line equation there so we don't have to waste a lot of time.
Professor,
Go ahead.
is the reason you changed the two equations because those were examples like that wouldn't be on the test, or they were just too difficult?
No, it's not that they're too difficult. I'm just running out of time. So I did two of these questions where the slope was a fraction. So I wanted to just have at least one of them not be a fraction. So we can just like save 5 minutes.
Got it.
Yeah. Okay, so this one here is 7. This one here is 2. And then this one here is the negative reciprocal. So over here will be 1/2. Okay. So over here, this is the negative reciprocal. Okay, and this still isn't bad because 1/2 times 2 is going to be -1. So every so often, the math gods smile on us. So you should get y minus 7 is equal to 1/2 x minus 1/2 times 2. Y minus 7 is equal to 1/2 x. And then this will cancel. then y is equal to a half x plus 6. Okay, so go ahead, copy that. And we will start the next section, but your quiz will be up to only this section.
Professor,
Go ahead.
I wanted to know which sections are going to be in the quiz, starting from which section and ending.
Sure, it's going to be, okay, so let me tell you right now. The sections on the quiz, all right, let's write it down, are all the sections we did this week. Okay. So the quiz will be on 2.3, 2.4, 2.8, 2.9, 2.10, 2.8, 2.9, 2.10, and 3.1, 3.2, and 3.3. Okay.
And how many questions are there going to be?
I have no clue. I'll have to play with it. Normally, I'm limited because I give you the quiz in class, and for every minute I give you for the quiz, is a minute I lose the lecture. So it could be anywhere from a half an hour to an hour. It won't be more than an hour.
Okay.
So in terms of questions, you're looking 3 minutes a question, I'm guessing roughly. So you go 3 minutes a question. For an hour would be 20 questions. If it's a half an hour, it'd probably be about 12.
Okay.
Okay. So it's one of those things where I've never created one of these. So I'm going to have to create it, and then I'm going to have to do it, and then I'm going to have to time myself. And probably what I'll do is my son he's learning this right now. I might just have my son take the test and see how long it takes him. And then add 15 minutes. So I have to figure it out. Now, if it turns out the time was too short, it was too short for everyone. And what will happen is that all the grades will be lower. But if you're the top student, you'll still be the top student. I'll curve it. So when I first started teaching, I went to UCLA, and the UCLA frame of mind is we're going to give you too many questions for you to do in the amount of time you have. So part of test taking is knowing which questions to tackle, which questions take more time, which questions take less time. It's more strategic. So you jump in there and you hop around. Now, that's not my intention for this class, because for this class, most people are used to going, I'll do the first one, the second one, and the third one. And if you're a good student, you should be able to just walk through all of them and then just be done and have about 10, 15 minutes left to just sort of breathe and double check. So that's my intention, but since it's the first test I'm going to do, we'll see how well I guess, okay? But just so you know, if you run out of time, everyone ran out of time. And where you will be exactly the same. So when I first started teaching, I used to make my tests a little bit too long. And then one test, I just got a little lazy. I made it a little bit shorter. I just ran out of time. I didn't have time to put extra questions on, and it was shorter. And guess what? The same people got the same grades. They just felt better about themselves. So when you take a test and then it just stops, it closes on you, you feel like crap, right? If you have a test and you have a little time, you feel better. So it doesn't really change your grade if the time is too short or too long. It's actually the same people will get A's, B's, and C's, but it's just how you feel afterwards. So that's why I'm going to do the practice test, and so that we all sort of have a sense of how much time you have and what your pacing should be.
Professor,
Yeah, go ahead.
since we're skipping 3.4 on the quiz,
Yep.
3.4 is still going to be due on Monday, or is that going forward to Tuesday?
It'll be due on, we'll cover it on Monday, so it'll be due like on Wednesday.
Okay, so then as of right now, there's no homework due for Monday?
No, there's no homework due for Monday.
Okay.
Okay? Yeah. Sounds like someone's killing a cat or something. All right, let's get going. Now, let's go to section 3.4. 3.4 is on domain and range, and most teachers really cut this down. They don't spend much time. I have students tell me all the time, oh yeah, we didn't really cover domain and range. And for me, this is one of the most important sections as a professional. Okay, so let's talk a little bit about function notation. Okay. Well, let's do this. Yeah, let's do that. Right? So this is called function notation. And for those of you taking pre-calculus and calculus, you will do this to death. Okay? Now, f of x is the same thing as y.
Professor,
Uh-huh.
is the name of this section domain and range?
The name of this section is, what is the name of the section? Is relations and functions.
Thank you.
Uh-huh. Okay. So we're working on today is section 3.4. Okay. Now, this is the same as this. Okay. Now, the reason why we sometimes like this notation, we sometimes like this notation, depends on what we're trying to do. When I'm trying to graph something, it's nice to have the y, because then you think about these points as x and y points. That's why we like the y. It's nice, x and y, okay? Now, if I was to ask you to graph this, okay, and let's say we were going to graph points, not do slope intercept. You would say, well, I need to plug in, well, I got a y all by itself. I got to plug in 0, 1, and 2. So then you would write, you would solve this problem. Y is equal to 2x plus 3. X is equal to 0. Y is equal to 2x plus 3. X is equal to 1. And y is equal to 2x plus 3. X is equal to 2. And if you did the math, it would turn out that you would get y is equal to 3. Over here, you'd get y is equal to 5. And over here, you'd get y is equal to 7. So now let's say I handed my answers over to someone. I go, y is equal to 3. And you go, where'd you get this from? I'm like, I don't know. Someone gave it to me. They told me y is equal to 3. You don't know what the starting value is, right? When you just sort of look at this, y is equal to 3. Huh, that's nice, but I don't know where the x is. So you have y is equal to 3, y is equal to 5, y is equal to 7, and then it becomes like, well, where'd you get this? I said x equal to 0, and I got that. I said x equal to 1, and I got that. And what happens is this conversation gets very clunky. Now, a different way of writing this is to say f of 0 is equal to 3. This is my x value. This is my y value. So when you hand this to someone, they know what x value it came from. Y is equal to 3. What did you plug in? 0? Oh, great. In the notation is the information of what x value I plugged in. So over here, we would have f of 1 is equal to 5, and f of 2 is equal to 7. So what the function notation does is that it does the same thing as this. Plug in 0 into here, but it keeps the information so I know where this y value came from. Now, if we were to use y notation, the way we would say that this came from 0 is that we would write it as a point. When x is 0, y is 3. When x is 1, y is 5. When x is 2, y is 7. So this is the same as this. This notation is just a different way of writing a point. Also, this right here, this is the same as when x is 1, y is 5. This over here, when x is 2, y is 7. Okay, now let me take a picture. Okay, so on just the basic level, x and y are the same thing. And when we write something like this, it's a different way of writing a point. Right. Now the next question would be, why would you do that? Why can't we just have one way in which we write a point? Okay. And the reason is this. Okay, so I'll let everyone copy for it a second, and then I'll move forward. Okay. Okay. Now let's talk about what the concept of functions are, right? What functions do is they encapsulize a bunch of operations. Okay. So when I have a variable, this represents a number. When I have a function, represents operations. A variable represents a value. Okay, so what this function represents is first you got to square a number and then multiply it by 2 and then add it to 3, multiply it by, and then multiply it by c and then add 7 to it, right? It represents a series of operations. Okay, so let's look at a real world application. Let's say that I have an employee. Okay, so I'm going to pay my employees $10 an hour. Okay. And then yesterday I texted everyone 2 videos. Please watch them before Monday because domain and range tends to be something that people struggle with. If you watch the videos and do it, you're fine. If you don't watch it, Monday is going to be a little bit different because most teachers don't cover it. And I'm going to cover it to death. And then tomorrow I'll tell you why. Hey, Monday I'll tell you why. Now, for me, I just started making these videos. I only have 1 viral video. So there's only, like right now, the only people who look at my videos are the people taking my class. Okay. But I have 1 video that broke through and that people are actually like from India going, hey, thanks for that video. There's no videos on this. And the reason why is there's no videos on that. And that is the domain and range function videos. So those that went viral. So I have hundreds of people watching that, not just whoever was in this class. So just know that those 2 videos are important. Okay. Okay. Now, let's say I make a function for my salary. The salary is $10 per hour. Okay. And then let's say I have when I hire someone, they need a table. They take up electricity. I need to hire someone to clean their area. So there's a cost that comes to having an employee. So just extra cost. So it costs me $2 per hour plus $10 because I got to buy him a chair. Well, let's make it 20 so we don't get them mixed up. Okay. So there's a couple things that you want to do, right? One thing you want to do is you want to say, well, what is the cost of an employee? Well, I've got to pay his salary. Let me make sure I'm doing it like the book does. Yeah, the book does it that way. And I've also got to pay the extra cost. Okay. So let's say I hire someone to work for me for 5 hours. Okay. So we call this my parameter. We call this my function. So I just want to know how much it costs me to hire someone for $5. Well, First, I got to pay him. And then I got to buy him his table. And I got to pay for someone to clean up. I got to pay for electricity and just wear and tear of wherever he walks on my in the office. So then this turns into, well, I'm paying him $10 an hour. And then 2 times 5, like that. So, okay, so he gets $50 for his salary, and he gets 10 plus 20, so he gets $80 total.
Professor?
Yep.
Where does the extra cost? What do you mean 2 hour plus 20? Is that so like every 2 hours or?
Meaning that if usually, okay, so if you're my employee,
right,
I gotta pay. So I'm gonna pay you $10 an hour.
Okay.
But that's not the cost to me. That's how much money you make.
Mm-hmm.
I gotta pay for a table. I gotta pay for a chair. I gotta pay for a computer. That stuff uses electricity. You also, your area has to be clean. So you're not cleaning your area. I got to pay someone to vacuum around your area.
Mm-hmm.
Also, the more time, as you use my chair and use my computer, there's wear and tear. So there's also, they break down. So usually, one of my old CEOs, he said, whenever you hire someone, just add 50% to the cost.
So the salary is just how much I'm making. That's the $10, and that's the $10 per hour, and then the $20 is the table, chair, and everything, and then it's 2 hour because every 2 hours it's kind of like a wear and tear, and that's how much you're going to be paying for that wear and tear.
Exactly.
Okay.
So some of the infrastructure is a one-time cost, right? I pay for the chair once, and some of the infrastructure is electricity, water, you use the toilet. I'm not terrible, right? So there's usually a per hour cost and there's usually a fixed cost.
Okay.
And it could also include benefits. It could also include insurance. If something falls on you, I want to make sure I'm protected. I mean, there's a whole extra cost that comes to you being hired. And so my boss always told me, you know what, if you just want to do the basic math, how much you're going to pay that person plus 50%, and that's what they cost me. Okay.
Thank you for the clarification.
Yeah, no problem. So the idea here with the reason why this is hard in terms of the homework is because they say F and G, and I don't know what the hell F and G is. In the real world, functions have names because we want to associate it with something. Now, let's say that I'm running a company. One person, right? Usually it's the manager of a team will figure out what the per hourly price is. Hey, programmers make about $40 an hour. Maybe we'll hire someone who's a little less experienced. We'll pay $35, but we'll train them. Or maybe I don't have time for training. So even though it's $40 an hour, but we need someone now, we'll pay $45. A little bit extra so we don't have to wait. The extra cost, my boss, who is running my team, he doesn't know what the infrastructure cost is. He doesn't know how much my health insurance costs are. He doesn't know what disability insurance costs. So this is controlled by somebody else. So a lot of times what will happen is that you'll have this Excel spreadsheet. One person is responsible for this, and one person is responsible for this. So what happens is you use functions to encapsulate work. So if at the end, the money doesn't I ran out of money. How did I run out of money? I'm responsible for this number. If this number is correct, it's not my problem. I'm protected. This is his problem. If this number is incorrect, that's the guy you yell at. So a lot of times you use a function at a real job to encapsulate my territory is up to here to make sure that this number is right. Your responsibility is to make sure this is right. Okay. And the reason why we use a function is that it has a name. I know that this $50 was salary. I know that this extra cost was benefits. So you use functions because it encapsulates something intuitively that we're actually using, okay? And we also use it to separate responsibility. Your job, my job. Okay, now, that's where functions come from, and that's why functions are in almost everything you use, right? Because they help give intuition to a whole bunch of math. Now, none of that is on the test. So let's look at what's on the test. Okay, so find f of 3. Okay. Now, everywhere, let's make this an x also. Okay. Everywhere there's an x, put a parentheses, or you might get the answer wrong. Okay. So you're going to put the 3 wherever there's an x. Okay. Put 3 in there. And then do order of operations. Do the exponents before you do the multiplication. Okay, so here is 3. Here is 3. Okay. So we do exponents before we do multiplications and additions. I'm sorry. And then when we have additions and multiplication, we do the multiplication before the additions. Okay. I don't know where these problems are in the XYZ, but if you look at all my sort of quizzes and finals and midterms, this is always the first question I put on my exam. Okay. So try doing it, and then if you make a mistake, you'll make a better memory. So try telling me what both of those are. Okay, now, this one here is okay. A negative times a negative is a positive. Okay, now, most people are comfortable with that. Now, in terms of this one, this is weird. It looks like that negative is connected to the 3, but it's not. So what this will happen is you'll go minus, because it's not connected to the 3. So 3 squared is 3 times 3, so you get a minus 9. Okay. Now this is going to come up over and over and over. So just know that we're going to see this over and over and over. Now the way I try to hammer it down is I made it the first question of a bunch of quizzes and a bunch of midterms, but I don't know where this question is in XYZ is, so I can't in this case. But just know that this is a core thing that'll come up over and over again. Okay. Now, because this is virtual, no one is arguing with me. No one's going, nah, that's not true. I don't believe you. But let me prove it to you. Okay. let's do this problem. Try doing that problem. Because I'm going to blow your mind. Okay, yeah. Most of you probably got 1. Right? You got 1 because, oh, you go 10 minus, 3 squared is 9. And you go, how come it's not positive? You go, because that's a subtraction. It's not connected to the 3. Right? You're like, yeah, see, that's a subtraction. It's not connected to the 3. So whether the 10 is there or not, that is true. Is your mind blown? Virtually, I get no response, unfortunately.
Wait, Professor.
Yeah.
How come the answer isn't 1 with the 10 there?
It is.
Oh, it is. Okay.
But I just want to show you the way we got 1 was that this is equal to -9.
Right. Okay.
So whether the 10 is there or not, that is equal to -9. Now we're comfortable with that being -9 when the 10 is there. But even when the 10 is not there, that is true. Okay. So leaving that up there, just know that this will come up over and over and over again. Do this problem. Plug that into that, right? Using the same alphabets. Okay, so let's try it. Now remember, anytime you do a substitution, anytime there's an X, you need a parentheses. If you don't put a parentheses there, it's going to be wrong. So this will be +9. You're getting this case over here.
Professor.
Go ahead.
So why do we automatically add parentheses when putting into a function?
Whenever you do a substitution, that's just what the basic rule is.
It's just a rule. Okay.
It's just a rule. Otherwise, it's arbitrary, right? Because if you had done this, then you would get a wrong answer. Right. So the way they sort of make sure that we all get the same answer is they said, just put a paren there, and then everything will be consistent.
And that's only when substitution.
Only doing substitution.
Okay. Otherwise, just if it's -3, no parentheses, just leave it.
Yes. So let's try doing something like this. And then say find. That. So we get f of, we get -5 squared plus, anywhere there's an x, we put parentheses. And in it, we're going to put a -4. So this one is disconnected from that 5. So you get -25 plus 16, which is -9. Okay, and then we're done. So there's a lot to go in terms of this section and the next section. Please watch the 2 videos. It'll really make your life easier if you see it before the lecture rather than after. Okay, and then anyone who wants to take off, you're free.
Oh, Professor,
Uh-huh.
thank you for clarifying that infinity sign. I was having a hard time with that
Okay.
yesterday.
Did you do the OO? Did it work?
Yeah, I'm the one who emailed you. I ended up figuring it out.
Okay,
And it
thank
worked
you.
just fine.
Okay,
So.
thank you.
Bye.
Thank you, Professor.
Thank you.
Thank you, Professor. Have a good day.
You too, thank you. Okay, so if no one has questions, Viviani? Let me make sure.
Yes. Hi.
Hi, how do you feel about what we just did? Is it overwhelming or? Are you gonna...
I feel okay. I have to go over the material that you've done this week. I've only done the first section, so I'll do that over the weekend. And I have a tutor, so I feel like I'll be okay.
Okay. And then what's your major?
Nursing.
Okay.
So my only question right now is when I went to register and I put in the permission code, when I get to the end, it doesn't say it was approved. It just says this class needs permission. And I've done it several times and it won't let me register.
Okay.
And I'm having a hard time finding someone to speak to.
Were you able to go to admissions at all?
I haven't, since I got your email this morning, I haven't been able to go there. When I call there, no one's there. So they're only available virtually.
Yeah.
But you said someone's there?
There should be someone there. Let me ask this. Because you're doing nursing, so this isn't part of your transfer thing for nursing, but I know that the nursing at Valley College is particularly sensitive about your math.
Yes.
Because what they do is they have this math exam before classes and after classes. And they don't actually have a math class. They give you a book and they say, learn it.
Yeah.
So they need you to be independent in terms of learning how to do dosage. They give you a workshop, like I teach the workshop on it.
Yeah.
But I know that they're particularly sensitive about a bad MATH125 score.
Okay.
Because you're like if you weren't starting late, I wouldn't worry about it at all.
Okay.
But if you add the class, I would probably add it as pass, no pass.
Okay.
So that if you get a C, just because you're starting late.
Yeah.
Because I don't know what your skill level is. And then
this is my first time in a college class since I was 18 years old. So this is all very old information to me that I'm trying to remember.
Okay. So, all right. So what I would do if I were you is take MATH134 with me in the fall. And the reason why is this. A lot of what happens in the that you have to do is you're going to have to take what's called the TEAS test.
Yeah.
So the TEAS test is a speed math test in nursing.
Yep.
And it has 3 sections. It has science, it has reading, and it has math.
Yeah.
Now, most of the math is from pre-algebra, fractions, decimals, percents,
Yep.
and word problems.
Okay.
Okay. Now, the problem is we don't cover any of that in this class.
Okay.
So the stuff that we're doing now,
Uh-huh.
none of it's on the nursing test.
Okay.
The 134, we actually start from fractions, decimals. If you take my class, I know exactly what's on the TEAS exam because I actually coach the nurses who are accepted but don't pass that test.
Yeah.
So I know exactly what's on there. So the Math 134, I made sure that the word problems and the percent problems, I make sure to really nail down the things that the nurses need to pass that test. We've already passed all the stuff you need for, we kind of skipped that in this class.
Okay.
So in the fall, I would take the 134.
Okay.
Now, what will happen is that the 125 and 134, they both end at the same place.
Okay.
So, but the 134 will cover a lot more algebra, especially if you're like, I haven't done this in a long time.
Yeah.
Then the 134 is better because we'll start at an easier place and we're only covering 1 section a day.
Okay.
Where we're covering 3 right now.
Yeah.
And then it would suck for you to go through all of this. And then you take your TEAS, you study for the TEAS exam and you go, you didn't cover any of this. And I'm like, yeah, I didn't cover any of that.
Yeah. So then are you suggesting that I don't take this class right now and just wait till the fall to take?
I would.
34?
I think it would be a better fit.
Okay. Is this one not so they're interchangeable as far as my prerequisites go?
Yeah, so technically you don't need any prerequisite. So you're going to go to Stat 101 after this?
To what?
You're going to go to Statistics 101, right? So technically you could just walk directly into Stat 101 and not take this.
Okay.
The reason why they want you to take this is because you're going to take chemistry, there's going to be algebra in it.
Yeah. So
for your own good, they go like, you're kind of going to need this.
Okay. Yeah, because I was when I was looking through the courses, I spoke with the counselor 2 days ago, and she was like, "Well, this is the one that's available. You can go into this one or into stats." And I'm like, "Well, I don't think I can take stats yet." So she recommended this one, but you're saying just skip this one and take 134 and then stats.
Yeah, and the reason why I know this is that I'm like, the nursing department talks to one math person. So like I'm the liaison.
I see.
So I'm the person who sits with the nurses. I'm the one who is, so legally, if you were to ask them, if you gave them truth serum and went to the nurses and go, what would you want them to take? 134. Okay. They're not allowed to say that legally because what's happening is a lot of people are not getting their degrees because they don't pass algebra and pre-algebra.
Oh.
And there's very little algebra and statistics.
I see.
So if you went straight into statistics, you'd probably be okay.
Ah, okay.
But you wouldn't be able to do chemistry and you wouldn't be able to take the TEAS exam.
Understood.
So the state does not care about you becoming a nurse. The state cares about you getting a degree. So when I talk to the nurses, they go, the problem is that we only accept 40 people, but we get hundreds of applications.
Yeah.
So if someone is not really ready for it, the state doesn't really care because they're not caring about you specifically becoming a nurse. Mm-hmm. They're caring about, as long as we have 40, the rest of the people are moving on with their lives. So,
okay.
Take the 134. Take me with the 134. Because if you're in my class, I'll tell you specifically what's on the nursing test. So then specifically those sections you pay attention to.
Yeah. Awesome. Okay. Well, I'm so grateful for your knowledge and thank you for letting me sit through this. I guess I won't register for this class and I'll just
Like if you were my daughter, I would tell you you're doing a lot of work. And the thing is, if you get a C, they'll notice.
Okay.
Knowing them, they'll look.
Yeah.
And I don't want to kill your chance before you even have a fair opportunity.
Thank you.
Okay.
All right. Well, this was really great. I will be seeing you in the fall for 134.
Sounds great.
Thank you so much. Have a great day. All right.
You too.
Bye.
Too fast, everything.
anyone else have questions?
Yes, I
Professor?
actually have a
Uh-huh.
question. You go ahead.
Oh, it's okay, you go. Mine's more of a personal question, I guess you could say.
Oh, okay. I have a question regarding the homework for section 2.10.
Uh-huh.
Specifically question number 15 and 17.
Okay. So
I actually posted it on the forum. I'm not sure you're able to see that on the XYZ.
let me see. I haven't looked at it ever, but let me see if I can find it. So XYZ forum. Ah, I see him. Perfect. Okay. Okay, so let's do the problem. All right. So I get okay. So we have 3x minus 1 is greater than minus 3. Oh, I'm sorry. 3x plus 1 plus 7 is greater than or equal to 4. And then you subtracted 7 from both sides, which is good. So then you get 3x plus 1 is greater than or equal to negative 3. Now the key thing here is that this is a positive number. Are positive numbers greater than negative 3? And the answer is yeah, positive numbers are bigger than negative numbers. So that's why your answer is going to be negative infinity to infinity.
Oh, I see. Okay.
Okay, is that better?
Yeah,
Okay.
because the 15 was the same situation, and I'm like, wait a minute, but it's the way I understood it was it's supposed to be undefined. Same thing for number 16, which I
It's
got that
only
one right.
undefined. Yeah, it's only undefined if this is equal or less than.
Oh, okay.
Okay, but if it's greater than, then it's all real numbers.
Okay, thank you.
Thank you. Okay, anyone else have a question?
And just to follow,
Uh-huh.
because at the moment, and this is kind of like following up with the girl with the nursing.
Mm-hmm,
My current major is environmental and occupational health, so it's basically like a chemistry major. And down the line, I could either go down the line of either being a health inspector or a nursing.
Okay, good. All right, good. Those ones are good options.
Yeah. So I can flip flop, and that's what my counselor told me. Now I know this section of math is going pretty fast, and I've been keeping up with the homework.
Mm-hmm.
But what are the sections that you're actually not touching on, which will, let's say, if down the line I decide to switch to something else, like nursing?
Yeah. Okay, so with what we don't cover are word problems. So the nice thing about the nursing test is you can use a calculator now. So they give you a 4-function calculator. So it has like plus minus, no exponents, but it has plus minus, divide, and multiply. So it used to be that you had to be really fast at doing decimals and doing decimals, and you don't have to anymore. The only thing that you're missing from this class that you would have in Math 134 is you're missing the word problems. So at the end of this class, I spent about a week and a half doing word problems, and I specifically emphasized the word problems that are on the nursing Keys exam. Now, if you say I want to do the nursing I'd like to learn it, I actually have videos for a lot of them, and I have worksheets. So if you if you skip it and you go, oh, I need it, just come talk to me, because I actually have, if you look on the haiku, I actually have worksheets for the nursing exam, extra worksheets that are free, and I have videos. So for a lot of them, you can watch the video and learn it, but you'd have to learn it on your own because I don't cover them in this class.
Oh, I see.
Okay, so I guess the question is this. If you want someone to walk through like the percent word problems with you, drop this, take me in 134, I can still drop you where there's no record of you taking this class.
Yeah, because
So I think we passed the drop deadline already.
Yeah,
Okay.
no, it's perfectly fine because I'm fine with the class because it's been a while since I've taken like a math class.
Yeah.
Because for my major I have to take trigonometry.
Yeah. Yeah.
So and then I've been doing a lot of crazy math in my chemistry 65 and general chemistry. It's heavy-handed on the algebra.
Yeah.
So
as long as you're comfortable, I'm okay with it. So if you decide to switch to nursing, come talk to me and I'll tell you what you missed because I know exactly what you missed.
Okay, perfect.
And I have videos and I have worksheets for them.
Okay, awesome. Thank you.
Oh, and the other thing too, the math lab, even though you're not taking a math test, the math lab will help you. So once COVID is done, you'll be done in about a year and a half, about the time that you're going to study for the test. Mm-hmm. If you bring my worksheets and the videos, and I'll tell you what nursing, there's a study guide to buy. I'll tell you which study guide to buy. Mm-hmm. What you'll do is you'll take it to the math lab and you just walk through there, and every time you have a question, they can help you there also.
Okay. Yeah, because I was planning on holding off on taking any of the science class that have laboratory because the previous semester 65, I was comfortable with the lab.
Yeah.
And then this semester it was just so off. It was whatever the environment was not the same. Like lecture, it was fine, but the problem was the lab. Like I was losing a lot of feedback.
Yeah, I could understand that. Okay.
So I decided just to opt out of like not taking any of my core science courses and just basically focus on everything else that I can.
Okay, good. Okay. So if you decide to become a nurse, come talk to me and I'll coach you up a little bit.
Awesome. Thank you so much.
Okay, no problem.
Thank you.
Hello, Professor.
Hi, how can I help you?
I texted you about some dates that I have for an upcoming surgery, and you told me to stay after class to talk.
Yeah, so let me tell you what sections I'm going to try to cover next week. Okay. All right. So
sorry.
Okay, now
I'm gonna write it down.
Okay. Now, if it turns out that you need extra time, talk to me. Collect all documentation, okay, of the stuff. It's not for me, because let's say you miss a week and you just can't catch up. You really shouldn't get punished for that. You should really get an excused withdrawal so it's not on your record.
Mm-hmm.
So make sure that as you go through the process, keep the documentation of the surgery. So in case you don't pass, it doesn't harm you at all.
Okay, but I'm doing a pass no pass either way, so I think
it doesn't matter. You don't want to get a no pass if you don't have to.
Okay.
You would rather have it erased from your record.
Okay.
Okay. Okay. So I'm gonna do sections. I'm sorry. So next week we'll do 3.4, 3.5.
3.4, 3.5.
Yeah. 4.1 to 4.3. I'm sorry. 4.1 to 4.1 to 4.3.
Mm-hmm.
And then 4.6.
4.6.
Yeah. And then, so how many is that? That is 1, 2, 3, 4, 5, 6. And then chapter 5, probably up to about 5.4. So everything up to 5.4.
So 4.6 and 5.1 to 5.6?
To 5.4.
Oh, 5.4.
Yeah. And then follow on the calendar. I've been pretty good this semester of making sure the calendar has what we cover every day.
Okay.
Okay. All right. And then I hope everything goes well.
Thank you.
And then if anything happens, communicate with me. So if you go like, you know what, I can't make this first quiz because this, or this, I can let you skip it without penalizing you. Okay. Or if you lose a week and you go, I need a little time to catch up, I can work around it. As long as you know the material by the time of the finals, I don't have to penalize you for learning things a little bit later than everyone else.
Okay, thank you. I think I should be fine.
Okay.
Because June 22nd is my first appointment, which is a Monday.
Mhm.
And then something on June 28th. And then my actual surgery on July 2nd.
Okay.
I said July 6th in the message, but
Uh-huh.
it was July 2nd.
Is it are you are you sleeping over or is it in and out?
I think I'll be in and out. I'll be the same day.
Okay. So
yeah, I'll be fine.
What you might want to do is do a screen record of the lecture.
Oh, about that. I think you have your settings so that it blocks screen recording.
Yeah, so okay. I'm not allowed to let you screen record. But what you can do on Windows is actually record everything that's on your computer. So if you disable it so it doesn't fall asleep and just copy it. So what they're afraid of, because we have a lot of parents here, is someone's little kid walks into the room naked and their camera's on, and then everyone sees their kid naked, and then someone puts it on Facebook and goes, hey, look what funny thing happened in my class. All of a sudden, our school is liable for like child pornography.
Oh, I see.
And one upset parent. So I'm forced by the school to like disable any recording. So you can't use this to record it, but if you use what's called a screen recorder, where it just records whatever is happening on your screen, that's between you and your computer. Don't publish it, but you can watch it and that would be fine.
Oh, okay.
Okay, so if you Google screen recorder, you could probably tape the lecture and then just come home and watch it.
Okay.
Oh, okay. Yeah.